Hey, hello. Oh my gosh. I'm here. I'm moving my mic this side. Oh, not that you know what this side is. Other side of my... Oh wait, I gotta move my cord. It's... process. In there. Nothing on the screen except for... I'm not gonna do mechanics of it. Oh, I don't know if this is gonna be better or worse. It might be better to have my mic over here because I'm kind of like hunched over. I don't hunch over. Not that bad posture. I say as my posture is actually bad. Am I getting up? I just forgot. What did I say I was gonna do? I was like, I was gonna move. Oh, I was gonna turn my music a little bit. Yeah. Turn up my gain a little bit too. I wonder if I turn up my gain, but I don't know. I wonder if I turn up my gain but leave my mic low, if the static will go away more. I don't know. Anyway. Hello, hi. We are gonna do some electrical engineering stuff first, which is fun. I think capacitor stuff, maybe? Let's see. No! Never mind, we're doing phasor diagrams. Oh great, something I don't know how to do. I love it when I have to do things that I just straight up... Okay, God, I really hope that he has something that's not a video for this. No, wait, lab 6... No, it's okay. I don't want to watch a video. No, I hate watching videos. It's 38 minutes long. No. Oh no. Oh god, metal pipe. I got so scared. I thought that was the video I started watching. I was like, why would he put a metal pipe in it? I was like, I don't... Oh no. Oh no, guys. Oh, fuck. Me when my lecture just doesn't teach. Oh, you know what made me... Okay. So, for a little bit of context... Let me pull this up real quick. So we're doing AC current, which is like the kind of current that runs in your house. Essentially, DC current is like, it goes in a circle like this. Like if you have a circuit, let's say that there's a resistor in there just so that, you know, and like let's say you like are plugged into your source or whatever. The current's gonna, why am I so laggy? Okay, anyway, the current's gonna run around like this, and that's DC current. And then for AC current, it's like you have a source, and the current kind of goes like this, but then it like goes back. So it like goes wee 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 wee. It like comes like back and forth. And so when you have like a resistor here, have I seen any creatures lately? Great question. Yes. I don't know why I like got so scared. I was thinking about this. I thought I saw like a giant seagull. Like a giant seagull this morning. But it was just a regular seagull. It was standing on top of a trash can. I got a little confused. But other than that, there's not a lot of creatures. That was you. Thought this was like a huge guy. I was like pretty hyped. I was walked around the corner. I was like, oh shit. I can see a huge guy. No, it was just a regular guy. He was enjoying some thing that people had left out on the trash. You like how I draw these birds? This is how birds are, right? This is basically the two genders. Okay, wait, this music is just a tad loud now. Yeah, my professor was trying to explain impedance, which is basically like the equivalent of resistance, but with alternating current circuits. And I was like, oh, it like... because we have like a sine wave that goes in, right? Because it's going back and forth like this. Your resistor is going to obviously change like the amplitude of that. So if you had no resistor, it would be like this, but if you add a resistor, it's going to be smaller. But it's also like, if you look at the voltage or whatever over this, it's going to change the wave itself, like the spacing of the wave or the phase of the wave. And I was trying to like explain that. My professor was like, he was explaining it so badly. He literally just didn't answer this one kid's question. I felt so bad. I was like, because the guy asked like, okay, what physically happens with impedance? Like what is happening in the wire? And I was like, it's just resistance. But because AC is happening, we have to deal with it differently. And my professor was like, well, you know, for a capacitor, when you put in a sine wave, you get out a sine wave. And I was like, that is not what this guy is asking. It was driving me a little insane. A little, not even just a little insane, a lot of insane. Makes me mad when people don't answer questions properly. Like they'll answer another question, they're like, you're not getting it. And it's like, yeah, because you didn't answer their question, you dingus. Okay. Okay, what do we think? Do we go guerrilla warfare on this? Or do I try to watch this 38-minute video? Spoiler alert, I don't think I'm gonna watch the 38-minute video. Wait, is he just giving us the answers? Wait a second, wait, what the? Damie video time? Wait, he's literally just going through... I've never watched one of these videos. I've never even opened one of these videos because, like, I didn't need to. I, like, knew how to do the pre-labs. He's literally just going through each question on the pre-lab and telling you how to do it. What? Wait. I mean, it's just a vector, right? I think it's just a vector. Sorry, I just looked over and saw that bird on the left there. That scared me. Okay, I need to get rid of these birds. They're gonna go to a better place. Where's my drawings folder? There they go, they're in my drawings folder. Wait, let's see. I have scary... Oh yeah, I have Vegeta. There's my numbers tier list. They're the birds. What is that? Brain things? That's the tier list. That's like clown time. What is this? What about whimsy? Oh, that's also cool. Oh, there's me exploding. Why do I have some of these? That's just Vegeta again. This is kind of beautiful. I feel like this is why I saved all these, because like where else would you be able to find great stuff like this? I don't know, probably lots of other places. Except the what about whimsy? That one's pretty good. Let me see all. I can see all of them without having to. I should just submit this to the... I have to submit, or I don't have to submit. I'm gonna do a piece for... Oops. A piece for... my... engineering, college thing. And I was gonna submit, like, a thing, but I should just submit this instead. I'm cleaning my room listening to the stream. I'm moving rooms soon since my parents are moving out. Strange situation. And I just found like a pitcher full of aquarium pebbles and marbles. Wait, that's awesome. I think you should live in there. Is that possible? Can you live in there? Yeah, I need to get rid of these birds. Alright. True? Okay, how am I gonna do this? Well, let me get the problem. I think that's a good place to start. I really feel like a lot of engineering is just like that one Mary Poppins song. Or not Mary Poppins, oh my god. Sound of Music. Let's start at the very beginning. And then let's go from there. They don't sing that part, they sing the other part though. Okay. What are we looking at here? The magnitude and phase angle. Okay. So I think the deal with these is just it's vectors. Maybe if it was a tad larger, I think you could fit in there. Maybe if you were a tad smaller. That sounded evil, I'm sorry. I think this is the magnitude. So, I don't know, we'll say like magnitude of, would it be V? I don't really know. I'm gonna say magnitude of V. So we'll say like negatives, I'll write my workout. Not that I think it matters, really. I'm literally a grub, bro. That's so true. I got really excited because the answer is 7. Because you added 6 and 1. Yeah, it's 7. Don't worry about it. It's not gonna be exactly 7. I think it might be a little close to 7. It's probably gonna be like in between 6 and 7. Actually, no, it's not. It's probably gonna be in between 6 and 5. Or nothing. I could just be wrong with everything. Sorry, I'm getting my calculator out. Let's see. Square root 37. 6.08. Did I do that right? Maybe? Sure. Fuck it, we ball. I guess volts. And then theta equals tangent inverse of, okay, so do I even explain this? This is weird as hell to me. Can I chew a gummy on stream? I don't have any gummies, unfortunately. I don't know, it's kind of interesting. Like, there's an imaginary plane that numbers can exist in that's kind of like the polar coordinates plane. So like it's based off of these like circles. It's like everything starts at the origin and has like a real component and an imaginary component. I mean, I guess technically this is true about Cartesian too, right? Like it's like a position vector. If you're trying to like locate this point, you would also have a position vector in Cartesian. But so you have your real component, you have an imaginary component, and you know, a theta that defines that. So to find that theta, we can do tan inverse of the imaginary over the real. So that would be -6 over negative. I guess I need to switch my calculator into... No, I don't need to switch my calculator into degrees. I'm chilling. Well, I should probably... Okay. Wait a second. Let me... What about tan inverse of, like, 1? Okay, good. We're in degrees. Sometimes I don't like to check if I'm in degrees. Sometimes I'm pretty lazy, is the thing. Efficient. It says it's 80. Does that make sense? I feel like that doesn't make sense. Because we just... The imaginary part is the big part. Oh, it's 1/6. That's why. Yeah, 9.5 degrees. So -1 over -6. 9.5 degrees. Okay, well, I can deal with that. Okay. Ooh! Sorry. Oh no. Oh, complex conjugates. Sorry, I just looked at... Let's just keep trucking. Okay. 14 cosine 100. So omega. Okay. I just said crazy things. 14 cosine 100 t plus 230 degrees. In this case, our theta is 230, or well, our phase shift is 230. I don't know if that's the theta that we actually need though, because they don't tell me anything. So, you know, I love that. Let's see what he writes. Oh, you know. Nothing. He literally wrote nothing. No, I really don't want to watch this video, guys. I really don't want to have to watch this video. It's a straightforward representation of I. It stands for the We're gonna have to listen to this guy. I don't actually know if this is my teacher or not.
6 minus j. Oh, minus 6 minus j. All you have to do is value correctly.
Sorry, I gotta turn this up real quick.
B is a straightforward representation of I of t. So it's a one-step answer. I of t is IP cosine omega t plus or minus theta. So you should be able to find the magnitude and the phase angle directly from there.
What? I have a video for you. Can you play it on stream? Sure. Well, depends on what the video is. But yes. Wait, okay, sorry. VP. That's the peak voltage. Where is my... What am I doing? I'm trying to find... I don't know. I guess I'm trying to find... Data? Oh, I don't know, man. Why is this so weird? I just want to find... Oh, okay. So, the... Oh my god, what is this? Gamma? Why would he use gamma? I sent it on Discord. Let me see. Why would he use gamma? Oh wait, I've seen a video like this. Okay, wait, how am I gonna get this to play? Is this just a... I'm gonna have to full screen this video. Okay, fine. Oh, there we go. Look at that. I've seen someone else do the same thing. Also, addition is not an expression, but... Oh, exponents? Oh. Oh, it's so loud. Sorry. Wait a second. Just explodes your ears. I did not realize it was that loud. Okay, I've seen division. Wow, that's so angry. Equals it. This is not an expression, guys. This is not an expression, but that's okay. I still appreciate it. How about we get an integral up in here? You're telling me like you could do an amazing integral dance, okay? Integral, or we could get oh, that's just integral, or we could get, what else is a good shaped thing? I saw somebody do like tangent inverse, which is like integral. Or not tangent inverse, just tangent. You could do parabola. Parabola would be a good one too. Like, there's a lot of funky boys, I feel like. We could do, what's like a hot... I'm just trying to think of, just cross my mind, what would an eigenvalue dance be like? You would have to like... You would have to shrink or scale yourself. Wait a second. Wait. Oh, that's such a specific reference. I don't know if anybody watched Scorpy's New Year's live stream this year, but there's Like the way that Wayne danced on on Scorpy's New Year's live stream, that is an eigenvalue dance. He just like he just shrunk and grew. Okay. I don't see. Here's my thing. I'm not sure if. Oh, maybe I can just like show you guys this. I mean, I can. There's nothing wrong with me showing it. Well, give me a second. There, real quick. So, the theta here and the theta here are different thetas, which physics loves doing. Everybody loves just putting the same variable names and just being like, it's different. This is a phase shift in terms of how far this little guy here, this point, would be over on this line, right? So like where we're starting our sine wave, sort of. So like, you can also think about it as like, if we're deciding that the beginning of the curve is here instead of here, right? So like if we shift it to here, then that's going to be, it's going to be offset by like pi over, what? That'd be pi over 2? That's by pi, and then, if we wanted to start over here, that would be by 2 pi. But in terms of this is a theta that is defining, it's driving the creation of the wave. So as we go around this circle, we're accumulating more theta, and it's making this axis go back and forth and create that wave motion. It's turning rotational motion to linear motion. But I don't really know if... Oh wait, maybe it is the same theta. Is he just goofing me? He might just be goofing. Cause wait a second. Maybe it is the same theta. Maybe because they call it theta, it's the same theta. But that'd be a little odd. I don't know. See, the other funny thing about this is that they electrical engineers, you guys know how there's this idea in math of the square root of -1. We call this funny little fake number I. Yeah, they just call it J. It's not I. It equals J. In electrical engineering, because I is current, and they couldn't call it the same thing. I would just call that 230. Glad to know that the phasors in my mic still like to transfer from going like this and then like talk a little bit, you know, like me talking. Just this. When I look at my when I went to go upload like my VODs, I would look at the waveforms on them, and there would just be a point. It would be like this. This is how loud it would be. Like the audio waveform would be like, bar would be like this. The box would be that big, and this would be the waveforms, and it would just be, it would be completely full. It, I don't know what's wrong with it. It's really just RMA, but I'm like lazy. What's the square root of 18? Anybody wanna check this one off the top of their head? 4.24. Sorry, that's good for you. and then theta equals tan inverse. It's gonna be 3, so that's gonna equal 45 degrees. Now, I'm not really sure, like, if they just want me to do complex conjugates for this, because I'm down to do just complex conjugates. Why don't we just try that? 'Cause that's what math tells me to do. And, you know, I like math, and I trust math. I also don't know why they're writing the J in front of the 3. That seems weird to me, because you never do that ever in any other thing in life. But, you know, electrical engineers, right? So this will be minus. I am so mad. It was. Well, how is it just. We did my demon. No? Okay, well, yeah. Literally. There we go. How do I feel about this as the Mike Demon emote? Base. He's got like claws. I drew the Mike Demon. I think his name is Ro, as in short for Pharaoh's Curse. Immediately the drawer. I want his eyebrows to be huge. His proportions are slightly off. I drew him before and I really liked the drawing it. He's definitely gonna have a place like in my... Once we exercise him and get him out of my mic, we're gonna save him, okay guys? I can fix him. He's so sneaky. Is that not big? Oh, that would probably ruin that. Anyway, I should probably not draw that on top of my electrical engineering. Put that up there. Here we go. Hidden again. Redemption arc? Exactly. Man, I can't believe he exploded my mic again. What a little snot ball. I was gonna ask 15J. Right, 12 plus 3. Yeah. Plus. What is that? 3 times 6, 18 times negative 1 over. Well, let's see, negative 35. This is gonna be negative 16 over negative 35 plus. Just, you know, classic everybody, you know, classic everyday numbers. 15 over negative 35. Okay. You know? So, we just put these in the thing, and then everybody's happy. 16 over 35 squared, plus 15 over 35 squared. Equals a number that we all know and love, right? Everybody's favorite number. I definitely know it off the top of my head. I love it when numbers are just like so specific. 0.626620, obviously. 627. I don't know. What is this in? Amps? Okay. Probably box my answers so much. You know, so we can see them amidst the insanity. It's ohms. Oh, that's nice. It's like an inverse of imaginary times the real, or I'm flipping it, so it's, you know, the 35s will cancel out. Still a negative. So as if my voice is a little gone as well. Negative 43. 5. 2. 3s. I don't know if they want it in radians. Don't know why you'd want it in radians. To be honest. Okay, this one. Oh wait, actually. Wait a second. You can just wait a second. Sup? Hello, Shbean. Sorry, that was so formal. Can I not just cancel out this 3 plus j on the top and bottom? What's happening here? Why would you ever write something like this? I saw this and I was like, oh, if I do the complex conjugate and I multiply both of them by 3 minus j, then I can cancel them out when I do that. It's like, no, I can just cancel them out right now. Am I not just like... Is this not just like basic complex... I don't know, man. Maybe I'm missing something and I'm gonna use 0. I don't really care. This is weird. It's literally just 1 also? Wait. Magnitude of I equals the square root of 1 plus 1? If you're not flexing your teacher's problems, how will they know your built diff? It's true. Actually, probably should know the square root of 2 off the top of my head. Why would I say that? That's the most unhinged thing I've ever said. No one should have to know the square root of 2 off the top of their head. And then it's the theta is 45. I don't even need to do anything about that. I don't know if that's right. We weren't really taught this at all, so that's kind of fun. You know. Alright, what's the impedance of a 5 something? I don't know why I said something. Right, literally written right here. 5, what is that? Millifarads. This lab is gonna be so ass. I don't know, I also don't know how my professor got so far behind. He just like didn't teach us what we needed to know. We were like 8 lessons ahead and then we were none. Your assembly class, low-key kicking your ass, dude. Assembly is... that's crazy. Oh wait, I need to switch my... oh no, I need to funk up. Oh, I am... guys, I'm kind of fucked. I don't know how to do the next problem at all. It's okay, we'll get through this. We'll get through this. Okay, one thing I know. Impedance of capacitance equals 1 over SC, which equals... wait for it. 1 over... C times 1 over omega j. Got him. Know that. I guess. It's fun when I get it, but when it's not working, the errors are so unhelpful. Oh god, that sounds like it's the worst. I've been doing MATLAB for one of my classes, which is not really a coding language, I want to say. It's kind of like the worst. If you like wanted to make something awful a coding language. Let's see, frequency equals 2 pi f. 2 pi omega. Wait, no. Omega equals 2 pi f. But yeah, its errors are so specific that like if you mess something up, like you will instantly know what it is because it's not even really programming. You're just like putting numbers into something. Is that evil? maybe that's evil. Maybe I shouldn't say that. Okay, I don't really know how this is gonna turn out. Also, I don't really know complex numbers, inverses, whatever. I don't really know how to deal with that. But that's fine because it's not my job to deal with that. Okay, so 5 times 10 to the 6th divided by 1,000 divided by pi. 1591.5 1 over j. Here we go. That's the number that I got. Woo! I don't know. That's weird. I don't really know, like, if the 1 over... Right now I'm writing sieve of Eratosthenes. Oh god. Eratosthenes. Wait. Eratosthenes. That's close enough. I was like, I'm close. I know how to say some Greek. I can do a little bit. I was a mythology child. I was a young lad. Didn't like reading about Sobek and Odin. Right, Odin, yeah, he's a guy. I got it. I was like, did I mess up one letter in there? With an I. Okay, 60, so IL equals this, SL. Nice. This is L times omega j. So I guess 60 times -6 times 1,000 I. J. Sure. Oh, so when if we multiplied them, the j's would cancel out. Not sure if that means anything at all. That's what being an engineer is. Not knowing anything, just hoping it will work out. Okay, 0 point. Here we go. That smiley face covers me, okay. That's my, I have no clue what I'm doing. Oh god. Draw a phasor diagram? I don't know how to draw a phasor diagram, bro. How much? Oh no. Might have to watch this video, guys. My worst nightmare, having to watch videos. I really dislike when I can't just read something, because people waste so much time in videos. Me included. Can't believe you guys... I actually probably wouldn't hate my own videos that much. 4x speed with subtitles. I don't know if I can do 4x speed, I can do 2x speed. I'm not gonna make you guys watch it because it's probably really boring. Like, the thing is, if it was a good video, like if it was a good lecture, then we could watch it. But I have zero faith. What is happening? Wait a second. Uh-oh. Okay, well, they're... This is Zuber behavior. 4x speed subtitles hitting an elf bar is so good. What is an elf bar? What? So cutting... Yes, I agree. Subway Surfers in the top left. Okay, the subtitles just said, I'm not really sure if I trust that. What the heck? Okay, wait a second. Well, now the video is just not loading. Oh no. Oh no, guys. Okay, let me, It's okay, I can take 1L. I like how I'm saying that as if I was taught this. You know, I'm literally just stumbling around in the dark. I'm a boomer. It's a nicotine vape disposable thing. I don't smoke anymore, so maybe it's an old reference. Maybe I don't either. I don't even have a funny response to that. It could be like the newest thing and I would not know about it. I don't even know people who vape anymore. It was like a thing when I was in high school, but like I feel like everybody kind of either developed a nicotine addiction or doesn't vape anymore. Okay, this is awful. That's good. Everybody I know at school does it. Really? That's really interesting. My campus is actually pretty health conscious, I would say. There's a lot of weed smoking though, which, you know, I mean, is not as bad as vaping for sure. But it's, I kind of, you know, honestly, I've been just living like a very blissful life. I haven't thought about the word vape in a long time. Ignorance is bliss. Why is this video not? Oh, there it is. Okay, I equals, okay, ZEQ equals R plus ZL. Okay, yes. Why does it say ZL equals 6-9? Graduated from UCSB, yeah, but I go to OSU. See Santa Barbara, right? Kind of close to me. Wait, close is that to me? Not super close. Yeah, UCSB has a little bit of a reputation. Okay, okay. If I say okay enough, then it has to work, right? Okay, so ZEQ equals 1 plus LS. Right? No. Yes. I just wrote it the opposite way, and that still makes it work. Equals 1 plus 5 times 10 to the negative 6 times omega, which is 2 pi f, so 2 pi times 60 hertz times J. Okay, sure. Not really sure how much that 1 is going to be doing for us, but maybe a lot. Because this is going to be 10 to the negative 6 times. Ooh, actually, it might be doing a lot for us here. Oh yeah, I lied. Wait, but it's 1... It's just... Is it 1J, or is it just 1? I don't know. This circuits? Yeah, it's circuits, it's phasor. Yep, that one. Just phasors. I don't know why I said it like that. It's pre-lab. I have lab tomorrow morning. God, I have a lab tomorrow morning. But we haven't like learned it. They haven't taught us it, so I'm just stumbling around in the dark. We're just having some fun. You know? I'm gonna assume it's not J. I think it's just 1. Because it doesn't have a J on it. I feel like they would have said if there was a J supposed to be on it. Maybe they wouldn't have. I could be lying. Who knows? I don't know. Alright, so that's, I guess, maybe that's C. And then I'm literally just looking at this thing and it equals V over ZEQ. Yeah, that makes sense. Because Z, like, is our equivalent resistance, essentially. 115 over... Sure. Over 1 plus... Yeah? We can complex conjugate this bad boy. Sort of unfortunate. Oh, I see. Okay. Wait, do I need the function of this? In phasor form and as functions of time. Okay. Right, so we definitely need to complex conjugate this bad boy, which is gonna be mildly frustrating. Okay, it's not gonna be that frustrating. So 115 plus. I'm gonna do the top first because okay, it's minus actually. I lied. Already lying to you. This times 115. 0.217 j over, we got square root. Well, this is gonna be a tiny, oh, it's just 1. It's essentially 1. Well, that makes my life a lot easier. I like that. So then, I guess like magnitude of I equals, I really hope everybody in class tomorrow morning just yells at him and is like, I don't know what a phasor is. Because I feel like that's the good ending. This is going to be 115 pretty much. I don't think the magnitude is going to be anything close to the 0.2. Yep, the magnitude is 115 pretty much. And the theta is going to be, what have we got? I don't know why I was doing that. I don't know if you hear me just snapping in the background. This divided by 1. It'll be very small. Yeah. You know, maybe he expects us to watch video. But I'm over here thinking, really it's my professor's job to like teach the lecture. Teach us the stuff. Might as well have a little fun stumbling around in the dark. Okay, so it's the math. It's like 115 cos omega, which is I don't know, 120 pi t minus, yeah. Maybe. The numbers could be off. The complex numbers could be off too. But like in my brain, I know about complex conjugates. That should hold true. They didn't just reinvent complex numbers and not use complex numbers. Otherwise, there would be 0 point to them being called complex numbers. But then again, you know, they just decided to call it J, so maybe it is. Okay, and then they say that it's XL times I. X.
Okay, and for both of those,
have
phasor form.
Phasor form, sure.
As well as.
Wait, but I want like, what is X?
VL will simply
L will simply, guys, voltage across the inductor
times.
Wait, what?
I.
Wait, you just said the. Okay, guys, so the voltage across the inductor is the voltage across the inductor. What is XL? What? Does he just mean like L? What's the voltage across voltage? And you're looking for voltage across. Oh, wait a second. Could I do like it minus? That was a really big thing I just said. I know that R is constant, right? So I know what VR is gonna be. VR is easy. VR is I times R. That's gonna equal. God, it is the exact same thing. Wait a second. Uh-oh. Actually, that's Not a good thing, because that means it's all the voltage. So isn't the voltage across the... Oh my gosh, hi Clem! Me with my voice cracking. Damie! Ayaya. I'm trying to stumble through. I don't really know why this is not working. An Ohm's law. VR is equal to R times I. Oh wait, should I be using the Z? Playing Roblox, I'm sorry, I didn't call I the fakeness ever. How are you? I'm okay, I'm recovering. My voice is a little goofed. I think this is wrong, what I'm doing. I'm not getting this right. I'm like kind of close, maybe? Wait. Maybe it's just times Z. Oh my poor Damie. I know, I literally only take L's on stream, but that's kind of funny to me. This would still be this. Maybe they could just share. Who knows? Maybe that's just how it be. Maybe these weird things that he's writing are Z's, not... I mean, that... Well, I don't really know what he's writing. It looks like he's writing, like... He's writing this. Anybody know what this... letter is? I don't know what that letter is. This other one he wrote it like that. I'm a little bit at a loss for words as to what this letter. We think it's like an I, but like he messed up writing the I. Is it like an R, but like you're too cool to write part of the R? I don't know. I really don't know, but he wrote it for both of them. Which makes me think it's a Z, but he didn't cross his other Z's. What the heck is this? I don't know. I don't know what letter he's writing. Look at this. Look at this man. Look at that right there. See that? This. What is this? Is he making up a new language? What does he say? Okay, EL will simply voltage across the inductor.
XL times
XL.
I. Ohm's law.
I guess it's supposed to be an I. I don't know why he would write them like that. But also, I don't know what... I don't know... Voltage across the... Is he gonna give me any more context here? Nope. My god. I'm going insane. What a horrible world. It's okay. This is just how it is. I'm gonna just pretend that it's gonna be Z. Because, like... Stretch, I got you. Hell no, drown it. Drown it Friday, Wednesday. Yeah, I will be. Oh, what was my toggle for? Was it wet? Oh, it was wet. Okay, that's my toggle for wet. And what was the other one? This one. It's not really math torn. It's just like well, I guess it's not great that I just put water on me if I'm doing electrical engineering, then I'm going to get shocked and I will die. Oh, I'm still... I don't know what I did to... Okay, no. Why am I still... How do I untoggle that? What is my toggle for that? I genuinely don't know what the toggle for... Oh, it drip? Oh, it's DRP. How did I manage to toggle that? See, it seems like horrors to me. It's not that horrors. The struggle. Now that you're a streamer, you understand. I'm so sad I haven't been able to make it to your... My Oshi, I can't support you. What am I even doing? It's okay, don't be sorry. I'm definitely making this up. He's gonna be like, what the hell were you doing? And our teacher didn't teach this, teehee. My Lunar New Year business. Busyness. Yeah, so true. Oh my god. It's been a lot. It's been a normal amount of... Wait, how did I get drip? Hello? Is it like on a timer? It might be on a timer. Oh no, we're gonna be getting drowned in Friday. Wet jump scares. I'm back. I don't know if you heard me say eto bleh, but there we go, I'm saying it again. Turning my mic down so it's less violent. It's really been annoying. You said something. I want to stream, but now that I know you're streaming, I just want to hang out. I know we want to stream at like exactly the same times all the time. Whenever you stream, I'm like, damn, Clem beat me to it. I wanted to stream. Except you stream a lot later than I do sometimes. And then I don't stream. Here. This is my, I hope if my professor, like knows anime, it'd be great. This is me saying, please don't, please don't be mad at me not knowing this. Rare damie art on stream. Drawing in the math category. Wait, I'll draw my classic outfit. My big jacket. I wear this big ass jacket everywhere. Oh my gosh, I should make that one my outfit. I captured it loud, the most violent. So serious too, so artistic. Okay, that was not what I meant to click. That was the button I meant. I'm normal. I'll put a little tie. So I'll just do classic. That looks like I have a tired eye. I do have tired eyes. You ever see me in real life? You'll know from the... Oh, that's Damie, for sure. So... when... Art. There we go. See, this is for the pity points. You gotta really know how to win an audience. You're in. Strike a lot of confidence. Self. So weird drawing myself without cat ears. sometimes the situation calls for it. Imagine seeing this as the problem. Dude, I right? Could you shit like this on every? Oh my god, you know it's. So for my dynamics class, we had to write a reflection on the midterm. We wanted to get some extra points back. It's basically like, oh, what are you gonna do like to study better next time and stuff? And I was like, wait till I tell him about. I tell him about my Twitch stream. I was literally like, I didn't like explain it though. I just was like, well, you know, I'm gonna stream more. Like, what the are you talking about? I also started talking about like, I was like, you know, I really need to make a floor plan for this class. I really need to draw a house plan. It's like, she's gonna look at this, she's gonna be like, what is this dude doing? The thing is, like, I'm not bad in the class, so like, she can't do anything about it, you know? Like, draw phasor diagram to determine resistance. I don't even know what the inductors reactance. What's reactance? Oh, guys, we are so boned. React. Oh no, I think I might have to watch this. Phasor diagram.
The graphical representation.
We're going to story time. Okay, we're gonna night core this though. How fast can we night core it?
Of the voltages that we measure in
Sound mix. In my history class, it's a Western civilization class. In our last test, she asked us questions about India and China despite not teaching us about them, and those are also not Western civilization. That's so real. Was it like, wait, was it like interactions with India and China, or literally just questions about India and China? They were definitely not Westerns. That's crazy. The leap.
By applying KVL. So if we take simple KVL applied to a DC circuit, let's say we have two resistors, we apply 10 volts to two resistors of 4 ohms and 6 ohms. The voltage you would expect would be 4 volts and 6 volts. So if I apply KVL and graphically represented it on the x-axis, let's say my current is the reference, it's lying on the x-axis because resistor does not have any phase angle. I start at 0, 0. My first vector for that resistor will have a value of 4. Then the second vector would start at the endpoint of the first and will have a length of 6.
I see, okay.
So starting from the beginning point to the end point of the second one would give me 10 volts, and KVL is satisfied. So KVL works. But for an AC circuit, it's very different. For an inductor, the voltage is 90 degrees ahead of the current, so it's typically pointing up if the current is on the x-axis. And for a capacitor,
okay. A second, let me see this. It was just about India. It asked what defined their caste system, and who invented a type of lacquer and the Qing dynasty. That's so specific. I mean, I know a little bit about their caste system because like I took like a world history class and we talked about like religion and stuff, but oh god, that's so weird.
pointing down. So if current is on the x-axis, capacitor is pointing down, or minus 90 if you will. So you see here. So you have to take the phase.
Wait a second. Wait a second. Wait 1 second. Exactly. No, the caste system was not from Western civilization. Wait, Wait, so it's about like Central America and stuff? Mostly? Wait, he literally said the opposite of this. Oh my god, wait. Okay, so what he said in class was that a capacitor lags behind 90. Oh, Greek and Egypt. Oh, that's cool. Wait, Greek's not. right? Not as Western. I mean, maybe. Where are you? I guess it depends on where you're standing in the world. He said an inductor goes forward. Oh no. Oh no. This is
Now
like
apply KVL. So in this case, let's say if I have a circuit which has a so this VL is not at 90 degrees. What happens is we have VR. Let's do this. We have VR starting from the origin, and then VL also has an angle. Okay, because VL is not just the inductor voltage; it is actually measuring the
this
inductor
is
voltage
so
plus the
bad.
internal inductor resistance voltage. Okay, in our lab we refer to it as V0.
Dude, my professor does not know what he's talking about, unfortunately, and like I can't
We call it as
do
V0.
anything about that.
So when we join these two together,
The thing is, like,
we'll show
he
some
worked at
voltages.
Lockheed Martin.
You see here.
Hope he knows what he was
And then
talking
what we do
about.
is we plot
Oh,
this to the x-axis, and that gives us the hidden voltage across that hidden resistor, VRL, and this
oh,
VL.
I see. That's kind of okay. It's like relative velocities. Just to, you know, use a relatable topic. Oh, how do we wait a second? Scuff. Wait, an inductor will have ideally zero resistance. Oh. Oh, okay. Okay. No. Yes, we do it. Okay. Turn on some music. Crying and dying. Okay. Let's see. We have to add some vectors. Yes. So, see, the thing is that's frustrating about this, not hard. Oh, the other thing is Z. Oh, both of them over. I see. Essentially, we just need to say like we did talk about VRMS. Oh, this is so scuffed. Don't do engineering. Don't do engineering. Take it from me. V RMS equals V peak over root 2. Okay, so we can find the peak. How do we get the angle? Do they give us a... They give us a current. Oh, I don't know. Wait, what do I even need? Wait, I need V's, right? Because I need to... I want to figure out the resistance RL and the inductor's accent. Sorry, the inductor's accent. I don't even... You know what? Chat? My pivot. A little bit of pivot. An hour. An hour is a decent time to pivot. I'm grinning evil. What if we just... I just didn't do this right now? Because I think I'm gonna have to, like, go, like, search. I'm gonna have to go on a journey. Oh my god, wait, they start drawing in GeoGebra? What is this? We pivoting? Yeah, I think we're gonna... Which is kind of nice, actually. Kind of works out well. I was gonna pivot after just doing it, but I thought it would be like... Actually, you know what? I didn't know what it was gonna be. I thought it was gonna be another... acid... document... thing. In and zoom out real quick. Brain. Okay. Okay, one thing I wanted to do was this is math. This is actually like more math than what I was doing. So playing a little something. So when I do stuff, when I like teach, what I think about subjects is that a subject is like a house, right? And the reason I think about them like houses is, at least for engineering, right? Subjects are usually skills that you have to use that um, stay with you, like throughout your life. So, like for example, linear algebra is a skill. It's a subject that you study, but it's not like a peripheral subject. It's something that you do to use as a tool throughout your whole life. So I think about it as a house because like you move into a house and then you live in that house, right? And so the way that I kind of think about studying for things is the analogy is like you have to build a house, right? Like you are the to truly master something, have to build a house yourself and understand how it's built and what you're doing when you're building. And it's yours. It's your house and you live in it. So when you're building a house, obviously you have to start with like some structural foundations like the concrete, all the other fun stuff, and frame doors and the windows and choose where all these things go and make your own sort of decisions about what things are going to look like. But the beams that need to make up a house are relatively the same. I mean, you need things at the corners and such. And so when I'm thinking about subjects, I've come to call the different skills that you need to master a subject beams, because like they make up the beams in this house of the subject that you're going to build, that you're going to live in. And so what I wanted to do was, for dynamics, do sort of a beam walkthrough, all of the skills that you need to put together actually have a foundational understanding of dynamics, right? And so like when I say a foundational understanding of dynamics, it's not like saying you can do every dynamics problem, right? And it's also not saying the math how to do every dynamics problem, because if you don't have math beams, if you don't have a math house that you live in, obviously you're not gonna be able to do, like if you can't do a derivative, you can't beams. So beams are sort of devoid of other tools that you might not have. These are things that are like only relative to the subject that you need to understand, and then acting on those, obviously there are different ways that you do that, right? Like you might be able to do dynamics with constant acceleration. You don't know calculus, and that's not like any worse than being able to do dynamics with varying accelerations if you know how to do calculus. No calculus, right? Yeah, I wanted to do like an actual design because the way there, for me at least, like when I think about subjects, one of the things that's kind of nice is I like to design the house like for each subject and kind of think about living in it for a while. And to me, they're all sort of different. So I don't know. I wanted to design it and see if we could put in those beams and stuff. But it just means that I'm going to draw a house, and then we can talk about like some other stuff. But yeah, I was thinking about it because my professor was, teaches dynamics. I think, okay, first off, I want to say dynamics is a study of movement. And so I want this to be very like organic sort of house. I want there to be a lot of things that are connected and maybe can move in interesting. I'm gonna actually take a chunk, some in here. Kind of small though, like yeah, I was thinking about it because my professor was teaching us these various things. I don't know, I was like, I don't think it's that hard. It's just like how hard you make something. I don't really think engineering is that hard. It's just about the place that you're coming from that might make it harder. When I said I was like, hey, I'm gonna study mechanical engineering. Whoa, that's so hard, dude. Good for you. And I was like, it's gonna be that hard. And here, and I'm studying it, and I'm like, no, really not that hard. And they give us a lot of leeway to like just fail stuff. If that makes anyone who's an aspiring engineer or scientist happy, that like that is what it is, because it really is what it is. It's not. You have some things that you need to be able to do, obviously. I'm gonna put like a level down. Kind of step down into it's like little. I think it's gonna be like it's like an Animal Crossing house size. It's not like a big house. Although I do want to make a second floor, I think. My like I have a couple like sort of like rules for like what these houses have to like have. It has to be like a livable house. So like there has to be like a bathroom. There has to be like a kitchen. All that sort of stuff. So also has to like look like I would want to live there. It also sort of comes back to like reclamation, and I think it's really important, especially when you're doing engineering, or if you're doing a major and you're not really too happy with like your professors or something in your actual major classes. It's really important to have ownership over knowing that like they're not going to ruin. I'm gonna put the fridge. Oh, God. You play the Sim. You know about fridge. Even I'm not an architecture. It's a very tall ceilinged house. I also haven't put any. I put a mobile. I feel like this is a 4B. Also big. A door, honestly. Is a door right by the kitchen really weird? Is it so peaceful? I feel like a kitchen door. Maybe like here though. Wait a second. Here? And there's like a garden. So like when you look out, and there's also like maybe like a bigger slide. Also, I will say I'm a sucker for like very open houses, especially like environmentally open houses. You know, people have doors coming off their kitchens all the time. It's strangely making me want to play The Sims. Oh yeah, for real. I'm such a fan of like open concept houses, or not open concept houses, but like I really like in Japanese architecture and other architecture, not only Japanese, but like that you could just open like a whole door and have it just like the outside be right there. You know, I love that. Okay, that's also there has to be a water feature. Because if there isn't a water feature, like, I really like water. Probably one of the reasons I'm mentioning strange baby lore. But I'm water in not drinking. It's like the physics of water. Something I especially like running water. That bowl with water always moving. You get me. You get me. Oh my gosh! Wait, I want to put a deer catcher in here. One of those little like. Towers. Okay, that has lost its. Cannot tell what that is anymore. There's the deer scare. That's. I feel like if I put 2 lines on it, I'll know. Yes, I love those. They're so cool. I think like thinking about it like Animal Crossing house designs is a very good way of. It like makes you use it like modest. I feel like they should be modest because sort of the idea is also like, or at least for me, like I want to have a connection to these houses. Right? Like for my data analysis one, it was very. It was that was one of the first times I actually like thought about this sort of idea of framework of understanding stuff or reclaiming stuff. Door slash window. Very open, and in the back can sort of like really like a conversation pit almost. But yeah, it was a very small sort of like apartment house. It was like I think it was very thin. I don't remember why. It was like thin, and then there was like it was like an upstairs, sort of like a New York kind of. That can be where the mobile is. I really want to have like exposed. Okay, as you can see in my room right here, you can see the exposed beams. But I love exposed beams, especially in kitchens. I don't know why. I feel like exposed beams in kitchens. Oh, they are just chef's kiss. Like you're gonna see it. Like maybe we could. Maybe I'll make it a loft. Where would I have the loft be? Let's say there's another beam. These two beams right here are gonna be like the big flex beam. These would be the beams where it's like, oh, you need to know this to know the subject. Make it a little bit short. Where the bedroom. I think there would be screens. I would sort of. Let's see. My geometry is, perfect. Why it's beautiful. Relic. Oh wait, I want to pop this up. Oh, this needs. Oh. Oh, perfect. Okay. Little. Oh, I really like this. Maybe there's like. Probably would be a bathroom over here. This would just be the front. Like this would be the. Oh, wait, yeah, I could do. Like storage here? Or like laundry. Wait, no, I could just put the laundry machine based. Why? I just like the look of it. Not a laundry machine. Oh wait, I need stairs to go up there. Where do we put the stairs? Don't add stairs. Oh wait, I guess I could. Ooh, we could have like the stairs here and then like storage like on half of it, Like, have the stairs kind of like go up and like the storage could be like underneath them. How would I draw that? Like this, I guess. See, like that's you get it. You get it. That's the stairs. I feel like if it's windows up here, like scary. A little scared. I feel like I'm watching you. I feel like it would just open, or maybe there would be some sort of. I feel like this is a very like. Clay. I feel like clay would do well. I think there's like a little reading. And this would be a little. A bathroom. A one bed. I'm not very good at designing roofs. What for a roof? Ooh, big roof. Okay, that's good. Kind of overhang a little bit. Maybe it has some ball type shit on it. I don't know, like there's a big ball on top of it. Like there's a ball just like rolling down it. That's dynamics. Ball and a little ball. Like, you know, I don't really know how they'd always be rolling, but it's magic. Don't at me. This would have. Oh, so you'll fall off the ledge. Hey, it'd be a dynamics problem. Fall off the ledge. When I live here, my brain, I get to the, I would. The dynamics probably fall off the ledge. Okay, the roof is making things a little cluttered to see. Maybe I should have drawn them. Good, I like that. I feel like it would be like crowded in the. But this is like not a foresty. I feel like it's a like there's a forest near, but it's sort of a bit in a turn. Oh yeah, I feel. It's a multi-tree. And maybe there's more hills. Maybe it's like only forest. I'm not very good at drawing the environments. I'm only good at drawing. I can draw a house. Pretty cute though. A bathroom. What else would you need? Am I missing anything like really obvious? There's like some storage. There's not a lot of storage. But, like you could say there's more storage. I could put some. You could also put like a storage thing. Maybe they're probably like I'm gonna say like a linen closet, but it's not enough storage. It looks good to me. Also, okay. I think this is also good because this implies that there's a complexity to the beam structure here. Because there is a lot of moving parts. If you were to try and build this out of wood, there's a lot of things you need to do, you know. It's more like there also is probably like a bathroom. Not that really matters. Okay, so one thing I do want to talk about is I like this a lot. I think this house. I draw myself in there. Okay, that's a big ass me. Me moving in. Okay. Now I have to make good on that offer. Okay, so the things that we talk about. Alright, let me big fun marker. Not let's see. So we have I don't know if I like the taper. Alright, I'm so like So judgmental about my markers. Amy's still alive? No, I died on stream. He blew me up with hammers. Okay, so we talk about kinematic. Flash. I guess like positional movement, I kind of positional, or like calculus playground, also good. Chronology for that one. This is a good marker writing. And then we have F equals MA. We talk. That's like balance or unbalanced, really. Balance. I don't really know. Like first dates, inner relationship. Because it only gets harder from there. Still be immature in F equals A. You can get away with it. Then we talk about work energy, which is like, I mean, it's still balance. Work energy is wave of just like zooming out. Oh, like intro to avoidance. Good way to think about it, because usually you'll use work energy if you want to avoid certain forces. Like, I don't really want to do that. Zooming out in that sense as well, where like you're like, I want to look at the beginning and the end. I don't want to care about anything in the middle. Whereas FMA is very much like, let's look at. Sorry, I have water in my. FMA is like, let's look at a changing picture at one moment of time and really get in there. Then we have momentum. Is, I guess, the best way to talk. Momentum is like, really like, art of avoidance. Or like, avoidance application, I guess, is more. That's one of the main things I think about when I think. You're just dancing around, trying to not get tagged by impulses. Very much like Goldilocks of in and like you have to do some analysis before, you'll do some analysis after, and you also have to do some analysis. I guess you just instantly after that. I guess we talk about collisions, but like, still impulses. Bodies are. Oh, I guess like you could also argue we should. If positional movement is. I mean, this like includes like relative. They're both very important things. Oh, just a big X through that. Rigid bodies, like, it's like kinematics 2. Kinematics 2. When you realize that all that you are is particles tied to other particles. Era of omega. I also don't really know how to write an omega. Differentiating it from W, I feel like my W's are barely. Oh, dude, that was good. I feel like you have to draw it like a cat mouth, big cat. Like, okay, it's gonna be insane to me, maybe, but like the best way I feel like to explain how to write an omega is just be like draw balls. You're gonna make it look like an omega if you draw it like that. Because if you're like, oh, just write a W, then people are gonna write W. That's not an omega. This is an omega. You know what this is? Basically. Okay. Like if you were drawing like a funny, you know, like a funny cat or something, and you just, you know, that's omega. You can say like draw a cat face, but like if I'm gonna draw a cat face, like it looks like a the Vegas A. Wait. Vicky. They're funny, okay? It's the best way I figured out how to write omega. But this is kind of all of, like, so this to me is, these are like your big beams. These are like, at least from week 1 to, what are we in, 7? Almost 8. These are like your big things that you need to know how to do. And so these would be like, so one of the, like this would be I think honestly, I'd say kinematic. Smaller. I don't hate like this one right here. I'm gonna draw on top of them. Perfect. This one is kinematic. Lovely color. That's a bad yellow. Addicts. Because you like need this, otherwise you will die. Is the thing. Your house is going to fall on your head. Like, Damie, what the fuck are you drawing even? I thought we were doing math. I'm so off the shits. Get clipped. No, this is math, bro. This is how I study. By thinking of houses that are. I just rode 2.5 hours in hella wind. That's dynamics problem, baby. Relative velocity. Sorry. That's kinematics, I think, that one there. And then I want to say like the other ones are like the big 4 corners of the house, because it feels like so like this would be like F equals work energy. It feels like that other beam is a little bit more like showy, you know, whereas like this one seems pretty integral. Sorry. Oh gosh, integral mentioned. Momentum. Obviously, you know, there are other ones. And then rigid bodies in the back. Oh, actually, you know what? This would be vectors. This would be vectors. I think it's really, really, really important to actually use vectors. Now here's the really love your vector. Yep. Because here's my big when we talk about trig, I still want to do a video on this that I talk about trig, right? When usually we teach trig, we teach triangles, right? And so like, oh my god, it was perfect example is in my engineering and my electrical engineering. Imaginary numbers, complex numbers, whatever. And we were trying to figure out like, okay, for the component of this that's in the this was A, this distance. This distance was A, and this distance was B. And he was like, and we know that this distance is 2. He was like, oh, what's A? Like, what do you guys know to use to like figure out what A is? And everybody was like, SOHCAHTOA, and I'm like, no. The best way you're ever gonna think about this, I think, at least for me, is if you think about this on an axis and you think about cosine being x and being, your life will be so much easier for all of time. Just like remember that sine is y and cosine is x. Use the unit circle. Because in any time, right? So let's say you have a vector that's like a very common dynamics example is you have a vector that's like upside down and you have an omega here or a theta here, right? And you're trying to define this vector. But this like the circle. You know what you can just do? Oh, in my brain, I'm flipping it sideways. What's this? So this is still the y-axis and this is still the x-axis. Oh, in the y-axis, guess what? I have x, which is cosine. Oh, the x-axis. Oh, that's sine. Wow. You don't have to be like, ooh, opposite. Ooh, no. Listen to me. X and Y. Unit circle. Always gonna be your best friend. At least that's my take. And I think not a lot of people know that. Not a lot of people do that. Not a lot of people have conversational relationships with vectors like that. Where it's like, I'm gonna turn you in circles and I'm gonna move you around in my brain until I can get you into a place where I can see that, right? Because at some point you don't even have to kind of turn it in your brain. You can just, oh, this is code. Because that's what it is. You just know that that's because it's X. On spin Damien circles till he's dizzy. Oh, the vectors like it in the washing machine. Don't worry about me. We're playing a game. Oh, vector and washing machine. Yeah, I was just like, also, there's so many little things like that you can use to make stuff easier for people to visualize. Like, it was just funny to me because, right, like I wrote these like this, but like my professor probably just copied it from the book. He wrote it like this, right? So it's just harder to see. No, there's no point to making it. Why not just label them with the distances, because we're all engineers. Label distances like this. Being a goof. But that's also sort of like where this comes from, right? Like if you look at this, and if I'm trying to say like, hey, so this is what I think is important, or this is a representation of what I think is important, you can kind of visually infer the importance of various things from this, right? Or like, what does it mean that kinematics beam is like out in the open? Obviously, stylistic choice, but like, the fact I put it there is pretty important because that's like, it's so incredibly foundational. You don't have that. It's very easy to tell if you don't have it, and it's something that you want to keep and like really be able to keep back at. I don't know. It's just something that like I do because I think that it's I think that it's cool more than anything else, really. Because like, when are you ever gonna see something like almost never, but it's a little. Would it help people? Maybe. But like something like this, because I wrote out like, for example, pull up my beams that I wrote for this, because I do written one as well. Like, sometimes it's also like a differentiation between skills that you need that are, I guess, kind of like hard skills versus soft skills. So soft skills that you might need to be able to like understand a problem and like approach problem solving in any given class, and then also just like what you need to know about the subject. Like for momentum, I said like it's the concurrency of your mass and velocity, how much you're inclined to remain in motion. It's always conserved, as force can knock off some of your momentum or give you some, but it won't ever jump around its own. like beams are just chonky little axioms that snuggle into your mind, and you feel very safe and secure. Like, yeah, momentum is conserved. It's like your velocity is not going to change unless something changes it. We know that objects in motion stay in motion till something acts upon them. It's a fundamental physical law that we all understand. Yeah, I don't know. It's like everything can be very, very simple. Like, for example, so we know momentum is conserved. So when we're doing momentum problems are about mass and velocity. It means that usually we're going to have changing velocities because masses don't tend to change that. Or if they change, then, the analysis is kind of harder. So when we see these like changing velocities, and something that's changing them, that's usually when we're going to want to analyze something in the lens of momentum. And we know that if we want to analyze something that's changing, we can look at it before, look at it after, we can look at it during. When we're looking at it during, we can look at the forces that are present that are also changing, right? Because normally momentum is about impacts. If you run into a wall, maybe we want to know how much force is impacted on you when you run into that wall, or an average force, that's something like that, right? So it's a very, I think, simple way of looking at things and just breaking it down into make sense to people. So like, well, actually, you have to do conservation of linear momentum in the x direction to find the answer to this. It's like, no. You have to add stuff together, bro. Like, it's okay. You can say the words add stuff together. It doesn't have to be that deep. I'm a little fish in here. Okay, I think I'm going to. This is a pretty good stopping point. I really like how this came. I'd love to do a 3D model, but I should probably work on my actual, or I work on 3D model of any other house. House tour, Wild Heart House tour. It'd be really. Think about how cool that would be, though. Like, imagine if, like, first day of class, you're like, "Hey guys, so I take you on a tour of everything you're gonna learn, how important it is relative to each other. And it's also gonna be in VR, so you can just walk into it and like see what kind of cool stuff we're gonna explore, like work with, what kind of feelings it might invoke. I think it's very powerful. Like, science is so emotional, but people are, yeah, science is cold. Science doesn't care about your, like, clearly you haven't done science. You haven't done science. I'm trying to. But I have to go over some. Yeah, because I was getting goofy on some of the answers, but it's almost always just little things that are like setup things or whatever, and it's like as long as you understand how to do stuff, always make that extra. It's usually like 95% of the way getting there is the understanding, and then if you were the person who like can't execute the problems but you can understand them, getting that last like 5%, it might take you a while because it's going to be stuff that is hard for you to work on, but it's not going to be like as hard as somebody who doesn't know what they're doing trying to figure out what they're doing. Email, I just should talk to that guy. We don't have a lot of great professors. There's a couple people. They're interesting. But it's because the pay is not very good, so people tend to go other places. Alright, I'm going to wrap up here. I have something to go to at 6. But, guys, hopefully soon. I don't think I have that much stuff to do, so I kind of might, I'll stream games this week. And maybe I'll do something with Clem if Clem's around. Me putting Clem on the spot right now. Play games together. No, I don't know. But I hope you guys have a good day. I hope you eat some good food. I hope you rest. That is really rejuvenating and not just makes you feel like Garbo. Next time. Bye.